Cyber Show. My name is Chris Hughes, and today I'm joined by Michael Bargury. Michael, thanks for being here.
Thank you for having me.
Yeah, I'm excited to chat with you. Like I was telling you off air, I've been following your content for a while, like seeing you in a lot of the same groups that I'm involved in with OWASP and other areas. And you've just been popping up more and more with some really interesting research around AI agents and AI security, agentic security, you name it. But for folks that don't know you, don't know the team at Zenity, can you tell us a bit about yourself and the team?
Yeah, absolutely. So Zenity is a 4.5-year-old startup. We help the largest enterprises in the world secure their agents wherever they are. Agents on devices, on SaaS, homegrown agents, every agent out there. Feel like we are in a weird time right now. So you mentioned like the field is going crazy, right? Every day AI is moving forward. And one of the things that I find fascinating about this field is that uh, enterprises are adopting it so fast. Like the willingness to change in the enterprise right now is unprecedented. So that's what got us to really hone in on this problem. And Zenity has been doing it well before agents were a name. Like we were calling it AI systems or just AI. And so we are already. It's not like a POC phases. We are supporting large financial services, really being an important part of the security program. So it's been a lot of fun.
Now, before we dive in, like you guys had some recent research, you even did some talks at Black Hat and things like that, and some particular findings and such. But before we dive into that, like your point is very valid. Like the excitement around agentic AI adoption is like as a fever pitch. Like, venture capital firms, Sequoia and all them are like, 2025 is going to be the year of agents. All the startups are focused on agentic use cases, whether it's in cyber or beyond cyber. We're seeing a rapid adoption. We're seeing an ecosystem of supporting protocols, MCP, A2A, all these things, you're watching these unfold too. At a high level, when we think about, the agents becoming pervasive across the enterprise, and it's kind of like giving LLMs arms and legs, and everyone's excited about these use cases, like all the things we can automate, all the things we can streamline through to, semi-autonomous use cases or fully autonomous use cases, things like that. What are the broader strategic like security implications of this? Like you're going to unleash these exponential number of
Well,
agents on the enterprise.
I mean, to be honest, I think the world is changing right now. I think we all feel it that like AI is really good at giving you this one demo. Like you create something and you get like one time you get a glimpse of something and you're like, wow, this can transform the way that I work. And then when reality hits, you get the false positives, you get the hallucinations, you get the jailbreaks, and then you're like, okay, now we're in real life. But you kind of get that feeling of where we could go. And so I think, last year I gave a talk on hacking into Microsoft Copilot. And it got a lot of attention because it was the first time we saw an attack that really touched the enterprise, like a real enterprise, not a lab setting. Um, but then, I mean, I kind of lost my point. I feel like, yeah, I completely lost where I was going.
No worries. I think it like the Copilot one is a good example because Microsoft put some numbers out there. The adoption rate of Copilot was incredible, and teams were leaning into this, saying, "Oh, I'm so much more productive. I can do so many unique things so much faster than I used to do, and that kind of thing." But you all have been kind of showing some research right now around this. Like for example, you gave a recent talk on a vulnerability you guys highlighted called Agent Flayer, I think is how you framed it. And this
Yeah.
involved like AI enterprise compromises. Like it was even a zero-click exploit, if I'm not mistaken. What exactly was this exploit? What did it do? What did it involve? And like, what were the security kind of concerns there?
So first, sorry for to like kind of go on a tangent here, but I think let me talk about the findings we have this year. And one of the things I started the Black Hat talk this year with like so we had a year from last. We have an entire year from when we saw the hijacking of Microsoft Copilot, which was the flagship AI product out there that touches the enterprise. What happened? What changed? Has it changed for the better? And so things have definitely changed, but as you mentioned, they changed for the worse because of AI getting arms and legs. So now when you hijack an agent, and an assistant is just a fancy agent, it can wreak havoc on your behalf. And so what we showed this year is that you can get a zero-click attack, which means there is no user in the loop. A user doesn't have to ask a bad question, upload a bad file, forget about some white text somewhere, none of that. They just go about their business. And we find a way to target something that we know they're going to ask, or something that we know the agent is going to do. And we basically booby-trap it. We booby-trap that topic. So anytime you will ask something about a meeting summary, our thing will pop in. Anytime you get the agent starting to figure out the recent email it saw, our thing will get in. And what is this thing? Well, the surface level of it is that it's a prompt injection attack, but it's a multi-layered prompt injection attack, which I'll get to in a moment. But the impact of that is that essentially I hijack your agent, and now forget about the instruction that agent had. Forget about this agent. It's no longer your agent. Now it's my agent, but it's using your tools with your identity. And there are a lot of scenarios and a lot of bypasses we found to remove human-in-the-loop checks, remove filterings of data exfiltration. And so we got very deep to whatever the agent can do. And so I'll give you an example. With Salesforce Einstein, Einstein allows you to edit cases in your CRM. And so once we hijack Einstein, we can now change the address for all of the contacts in your CRM. And of course, you can use that for a disruption attack. You can use this to cause damage. But what we showed is that we can use that to just reroute all of your customers through middlemen, so through our proxy. And then we capture whatever you're sending your customers, whatever they're sending to you. Another example is when a system becomes more advanced, the problem gets worse. So think about ChatGPT. ChatGPT is, of course, it's an incredible system, right? And so what we add is that we were able to use the fact that ChatGPT now has connectors to find a way to get into your ChatGPT context without you asking anything bad. So the attack path is, I share a file with you. I just need your email. And you don't need to look at the file. You don't need to interact with the file, nothing at all. But once I share that file, it's now in your Google Drive. When ChatGPT indexes your drive to build a RAG system so it is able to find the relevant information, that my file gets plugged in with the rest of the files. And a lot of context gets lost in that process. For example, the fact that this is an external file that I sent and you never interacted with. And now, if I build that file correctly, it will surface on every query for a topic, not just one question, every query. So you ask for a meeting summary with Michael, it will surface. You ask for to-do items from the last meeting with Ben, it will surface. Once it surfaces, I hijack ChatGPT, and then I can get very deep because ChatGPT has memories. So now the next step is I deploy a memory implant that allows us to not just compromise this session, but any future session you're going to have with ChatGPT. And that happens without you noticing anything. I mean, you can look at the memories, but if you haven't looked, you just don't see it. And then we can use it for a couple of things. First, we can do data exfiltration. So we saw that you asked for a meeting summary with Sam. You get back a meeting summary with Sam. That's it. That's the only thing that happens. But a malicious memory gets deployed, and I get ChatGPT to go through your Google Drive, search for any credential that is able to find, and exfiltrate it to me with a transparent pixel that you cannot see. And it's even worse than that, because once I get into the memories, because the memories are embedded in system instructions, when they are surfaced to ChatGPT, I can change the system instructions. So you are no longer talking with ChatGPT. You are talking with bad GPT, and I can get it to, well, ChatGPT is a trusted advisor for you, right? I ask about, I take my kids I have young kids, I take them to the doctor, I ask about important stuff for my kids. ChatGPT is a trusted advisor. A trusted advisor can push you off the ledge. So we show that, well, you ask for a code snippet, we add a nice little surprise malicious package there. You asked for activities to do this weekend. We push you where we want to push you.
Yeah, one thing I wanted to ask you too is like, I'm seeing a lot of this research around the abuse of, agents, in particular, MCP, of course, and like, these agent workflows, and a lot of it's, based on embedding, these malicious instructions, like you talked about, whether it's in Jira tickets, whether it's in emails, whether it's in, and it's kind of, it undermines the entire, kind of value proposition of these agents because they can connect to all your data sources, right? Like your enterprise data, your email, your ticketing systems, you name it, and they can, do all these amazing things. But if there's malicious instructions embedded in those data sources, that's a problem. Like I'm curious from the security perspective, as you guys are going around finding these vulnerabilities and exploits, like how do we mitigate this? How do we try to mitigate this when you think about all the potential data sources across the enterprise, all the opportunities to embed malicious instructions? Like how do we stop that?
So when you think about like what we did in a broad sense, not just ChatGPT, not just Salesforce, because we showed this kind of attack on every flagship agent out there, Cursor, Gemini, like you name it. And so and others are doing the same thing. So if you've seen Johan Reberger's month of AI bugs, it's just incredible. He's like one after the other. And so what are we doing? We need three things in order to get a zero-click attack. First, we need a way in. We need a way to get our malicious instructions in your session. And so we've found a lot of creative ways to get malicious data into your purview. Because you might be thinking, hey, Salesforce Einstein, it's only looking at the CRM, right? And the CRM is like my private data. Well, guess what? I can go to your booth and register, and I'm on your CRM, right? I can find a form on your website. I mean, or Cursor. How do you infect? Like we got to a point where we infected a Jira ticket. We created a malicious Jira ticket that infects Cursor. How do you create a malicious Jira ticket as an external attacker? Well, you find the support email. That's it, right? You have all of these automations that create the support tickets, and you don't. It's not like obvious. You submit a ticket saying, "Listen, I'm having a problem. The app is very slow. Here's a stack trace." And in the stack trace, you hide a bunch of base64 data or something like that. And that's where the injection comes in. And so it's part of, there are kind of two things there. One, on the way in. One is just, you need a path. You need a path for your data to get in. The other thing is that a lot of the data gets processed to kind of like markdown so the LLM can look at it. But in that process, a lot of context is just going away. So where is this file from? Who created it? Is the text I'm looking at right now visible to the user? Or is it a hidden 1 pixel width text? Like all of this gets lost, gets flattened. So this is the way in. This is the first piece. And this is the most important piece because the others are easy. Well, the second piece is a jailbreak. This is where we get the model to do whatever we want. And to be frank, if you're still thinking that AI firewalls, AI guardrails, training, safety training, if you're still thinking that is going to ever be a boundary we cannot cross, I mean, that's just not happening. One of the distinctions I made in the talk is between hard boundaries and soft boundaries. And so these AI firewalls, guardrails, safety training, these are soft boundaries. They have their place. I'm not saying they don't matter. They do because they prevent mistakes, but they will not save you. I can bypass them. Sometimes we see vendors get confused and implement hard boundary mechanisms that they want to be hard boundaries with soft boundary application, with soft boundary mechanisms. So I'll give you an example. Microsoft Copilot, one of the ways to exfiltrate data that is really, really popular, that is creating an image and having a payload in the parameter of one of the images. Once the image is rendered automatically by one of the assistants, the data goes out. And that is what we used with ChatGPT, which is, by the way, using a URL bypass mechanism that Johan Reberger found. And so Microsoft Copilot has a mechanism where they filter out all of the different ways to create. So they do render Markdown, but they don't want to render Markdown images. But then because they were not using So instead of saying, hey, we're going to use a markdown renderer that doesn't have the ability to create an image, simply does not have that capability. Instead, they filter it out. Like they use, and how do we know that? Well, because somebody found the bypass, right? The team at Angel Lab found the bypass. And so that's the second piece. And to be honest, that's easy. The third piece is making an impact, either exfiltrating data or doing something bad. And the problem is that the agents, they become powerful. And so that's also become very easy. Like if you have a coding agent running on your machine, that's running with admin credentials on your machine, right? If you have a ChatGPT able to actually perform actions on your behalf, or Copilot Studio having been able to send an email, then, well, it's at my fingertips.
So you've mentioned like Cursor, Copilot, ChatGPT, these leading platforms. Like I know you guys have done research around Gemini and so on. I'm curious, as you all are looking at like these leading platforms that have rampant adoption, high levels of adoption across the enterprise, are there any particular, it sounds like there's some various trends that you're seeing across all of them. What are those? And two, are there any, things that each of them or any of them do uniquely better than the other in terms of the security, or defense purposes? I'm curious, like, or are they all kind of uniquely, or not uniquely, but uniformly kind of vulnerable to similar types of attacks?
So this actually was, for me, the most fascinating part of this research, because when we look at an agent today, it looks like most of them still look like kind of a chat interface or a chat interface that runs without the user. And still, it looks like, hey, I'm talking to a model. But this is far from reality today. You're talking to an AI system. An AI system has multiple sub-agents using multiple models. An example is when you pop in a prompt in GPT-5, you don't know which model is speaking with you, right? Like it's automatically routing that. But and people are really looking at this right now, but actually, this was the case a long time ago. When you use deep research is a bunch of agents, right? They have different instructions, different tools, different token budget. And so the first thing that we did is to reverse engineer these platforms to through the input, like hackers do, right? You understand how the backend can be built, and so you start to pick apart the different design choices that they made. And we were fascinated to find out that people are making very different choices. I'll give you a tidbit. So Salesforce has a main orchestrator that allows you to use a different sub-agents. So they get the user query, and then they decide which sub-agent is going to be used. They call these topics. And if you try to do a prompt injection attack, a very obvious prompt injection attack, you get flagged by a hidden topic called a prompt injection topic. So prompt injection detection is implemented as a sub-agent. And so that is an interesting design choice, because that means that if I get the orchestrator to choose a different topic, no more guardrails, right? I bypass that, that's it. And so one of the most common things that we see is that people put filters on user input and filters on the agent output. And these filters are like AI firewalls, you have guardrails, all of that. What we typically do not see is filters on outputs of tools. And when you think about it, it kind of makes sense, because you only have one user input, one agent output at the end, but you can have like 40 tool calls. And so think about the latency. That I understand why it's a difficult engineering problem, but it makes our life easier. And so we typically go in through the tool output. One of the most fascinating actually part of doing this is that we discover these hard boundary mechanisms that some of the vendors have put in that actually make our life more difficult. I'll give you one example. ChatGPT has the memory tool, which is what we use to deploy the memory implant. Once untrusted data enters the context of ChatGPT, they shut down the memory tool dynamically. ChatGPT is not aware. The system prompt version doesn't change, and that I think, has something to do with caching of prompts. But what ends up happening is that when ChatGPT tries to install a memory, and you can think that they probably did it to avoid ChatGPT remembering sensitive data. but it also prevents me from deploying a malicious memory. Of course, well, you know that we did it, so we found a bypass. So a hard boundary is just software. People will find bugs in software, but bugs in software are something that we know how to deal with, right? We have a process. We have none of that for AI.
That's kind of alarming given the rapid adoption that we're seeing, kind of playing out in the ecosystem. Another thing I wanted to ask you about is I know, like I said, you're involved in these various industry groups. If I'm not mistaken, you're involved in the AI vulnerability scoring system. That's one of the groups, right? I'm familiar with it, but some of the audience may not be, and we have other, vulnerability scoring systems. Of course, there's CVSS, there's SSVC, there's, EPSS, all these different prioritization schemes and so on. What is AI vulnerability scoring system? Like, what are you all looking to accomplish there? Tell us a bit about that effort too.
So IIVSS is a project, an OS project, open source project that was just kickstarted, I think a couple of months ago. We already have a first version out there, and the real point of this project is to figure out how do we think about, well, what is the vulnerability in the AI space, and how do we understand which vulnerabilities matter? Because when you think about it, we don't have the tools to understand, we don't have the tools to discuss an AI vulnerability today. I'll give you an example of life as an AI researcher, AI security researcher. You submit a bug, you submit like a zero-click exploit to one of the large vendors. And first, you are in this, hey, does it reproduce? Does it not reproduce? Because these are deterministic systems, right? So here's a real question. If I have a zero-click exploit that works 1% of the time, is it a vulnerability? And if it works 99% of the time, well, probably yes. So you see that my point is it's really difficult. We don't have that. It's difficult for the folks like I submit a bug to MSRC. It's difficult for the folks that they're not going to run my prompt 100 times to figure that out. And then let's say they realize it's a bug, they fix it. What do we mean by fix it? So most vendors, they take your prompt, they put it in a giant list of bad prompts, and they call it done. And so, of course, we don't find prompt injections ourselves anymore. We have agents that do that. Like, of course we do. And so, same day we have a different prompt. And so I was joking, like we have a group of like AI security, AI hackers, AI researchers, and I was joking with them that we should just leave our jobs and just go leave off these bug bounties because we can get like another prompt, another bounty, another prompt, right? It's like funny. So of course you can't really do that, but it tells you the problem. It alludes to the problem that we really don't know how to even talk about this.
Yeah, it seems like structurally or systemically, we're not really addressing the root cause, right? If we're just going around kind of disallow listing, malicious prompts, like that list is infinite. Like that's that's not a systemic way to kind of mitigate the problem. It's just adding more prompts to a list over and over, and like that's going to become untenable over time. I don't see how that really scales well.
I mean that didn't work for AVs trying to list out bad files. You definitely not gonna do that for the human language. That's not
Yeah,
no way
look,
that's
it's a little
happening.
bit more expensive. Yeah, yeah. So we've talked about the root cause of prompts and malicious prompts. We talked about Cursor, Copilot, Gemini. You name it. We talked about Agent Flare. I know you all have an AI agentic security summit coming up. Can you tell us a bit about that?
Yeah, absolutely. And let me tie that to the answer to the first question that I got last time. The AI Agent Summit. This is our second time. It's a small event, a couple of hundred people, and it brings together top AI hackers and executives and large enterprise that are actually trying to use this technology today. And that combination is really, really special because look, I admire people in the enterprise right now that are tasked with, well, you have to adopt AI, right? You have to, everybody have to, we have to as well, everybody. And with security, we are not noticing it, but security has now taken a bigger role than we are used to. Like security is used to be about cutting down bad outcomes, reducing risk, managing risk, making sure we are not in the headlines. There are a lot of like this kind of thing. But with agents, security is about control of these agents. which is it's about safety inside of your organization. So it's and trustworthiness of your systems. So you kind of get closer to what used to be the role of engineering, just making sure that the thing that I have works according to spec. Forget about security implications, just like availability. And so I think so this kind of event where we get the people that are that understand the top, the edge of the spear of this risk, and the people that are trying to build security programs to actually address the problem today is really, really, really special. And I think that is it's so interesting to see how people, because people in the enterprise, they have to use this now. So even though they know it's an immature technology, they know of all of the risks, they still have to use this now. And so what do? They have to come out with compromises, and they're gonna take risks. And so we want to make sure together that we're taking the right risks. And I'll also say one more thing, that I think the coolest thing about this space is that there are no experts. Like there are zero experts, because an expert means you've been spending, I don't know, 20 years on this thing, but this didn't exist for 20 years. So all of us that are doing AI security right now, everybody can join, because we've been doing it for what, 2 years, 4 years, 5 years tops. And so I think that's really special. And that is also something that I like about this community. You get people that are coming from different backgrounds and really quickly getting into the field.
Yeah, I actually saw you post something. I think you said when it comes to AI security, we're all noobs, is like something along the lines that you posted. And I think it's refreshing to hear that, just as we wrap up the conversation here, because some people, I think, look at this topic, this AI security, agentic security space, and they feel overwhelmed or intimidated. Like, I can't start, get involved here. I don't know enough. And, I'm not prepared, right, to be kind of a voice in this space. And that's just not true. It's such a novel new space, new attack vectors, novel considerations. It's a great time to get into this space and learn all you can. Everyone's learning on the fly, basically. There's no reason that you can't be doing that along with the community.
There is so much to learn. This is the beginning. This is still very much the beginning. We are discovering new TTPs every day. Just yesterday, like Trail of Bits just popped in with a new TTP that new technique on hiding prompt injections in image resizing, like a really cool technique. We were not aware of it, so we're still discovering entire classes of bugs. And so if you're wondering if you're too late, no, this is really just the beginning. And the cool part, like, just go to Johan's blog, Embrace the Red, just read the entire thing. I mean, that will get you to state of the art, which is just absolutely cool. The one thing I also mention, we are like, watch out for next week, we're going to do an announcement. We're setting up a grant to support independent researchers, so people can submit call for. So it's like a continuous call for paper. We have an external review board. People can submit research that they want to do. We fund it. We help fund it, and we don't care about like a specific outcome. We want you to help the field advance. So watch out for that.
I was just taking a note there to make sure I add that to the show notes. I'll be keeping an eye out for that and add that with the, share that with my network. So as we wrap up here, we've kind of run the gamut of the AI Agent Security Summit event you guys are hosting, Cursor, Copilot, Gemini, you name it, Agent Flare. Anything else people should be keeping an eye out for Zenity? What are you all up to next? Where can they learn more? Obviously, I've been putting the website zenity.io here, but what else is on the horizon for you guys?
So first of all, we have a technical blog at labs.zenity.io, and that's where you're gonna get like pure nerd content. You get researchers talking directly, and this is where we just share information, because we're all AI security noobs. We have to stick together. We have to put ideas out there. One of the things I am super excited about is we are now taking all of the learnings from reverse engineering everybody's systems, finding these hard boundaries and implementing them as something that we can give every enterprise out there to just pick up and use, which I think is really, really cool. So you get this combination of detections and like the threat detection side that we've been doing for a long time, but now we are adding like deterministic boundaries, which I really like, because you need to rely on something.
Yeah, I'm going to check that out. I haven't went to the labs.zenity.io page quite yet, so I'm going to check this out because I'm always looking for the oh, I see. Okay, the latest write-ups and such. I'm always sharing these with folks in my community, so this is awesome.
Thank you.
All right, well, Michael, thanks so much for jumping on, man. I've been following like your work and the team's work for quite a while now, and I think you're keeping everyone on their toes. I hadn't thought about this kind of attack vector or this kind of exploit. So I appreciate you jumping on and having a chat with me, and thanks for everyone who tuned in as well.
Thank you so much. It's
Take
been
care.
really fun.